For most of human history, the stars appeared completely unreachable. They were points of light scattered across the night sky, separated from Earth by distances so enormous that even imagining a journey between them was difficult. Then astronomers discovered something extraordinary. An object had entered our solar system from interstellar space. It was identified as 3I, Atlas, only the third confirmed interstellar object observed passing through our cosmic neighborhood, after Oumuamua in 2017 and Borisov in 2019. What makes this object different from an ordinary comet is its trajectory. Objects belonging to our solar system generally follow paths controlled by the Sun's gravity. 3I, Atlas, however, follows a hyperbolic trajectory. In simple terms, it is moving through the solar system rather than becoming a permanent member of it. It came from somewhere else. And eventually, it will leave. That makes 3I, ATLAS an incredibly valuable scientific target. Imagine finding a piece of material that formed around another star without ever having to travel to that star. That is essentially what astronomers have been given. The object may contain frozen gases, dust, and other compounds that preserve clues about the environment in which it formed. Our solar system is only one planetary system among an enormous number of stars in the Milky Way. Until recently, scientists had almost no opportunity to directly compare material from our solar system with material formed somewhere else. Interstellar visitors change that. Early observations showed that 3I, ATLAS behaves like an active comet. As it approached the Sun, increasing radiation warmed its surface and caused volatile materials to escape. Gas and dust surrounded the central body, producing a coma that made the object easier to observe. But its chemistry attracted particular attention. Observations suggested significant carbon dioxide activity, while water appeared less prominent than researchers might expect when comparing it with some familiar comets from our own solar system. That difference is scientifically interesting. It does not automatically mean something artificial is happening. Instead, it could tell us that 3I, ATLAS formed under conditions that were different from those experienced by our own comets. Perhaps its birthplace was colder. Perhaps its original star system contained different chemical proportions. Or perhaps its surface was transformed during an incredibly long journey through interstellar space. These questions cannot be answered simply by looking at an image. Astronomers need spectroscopy. Spectroscopy allows scientists to analyze light and identify molecular fingerprints. Different molecules interact with specific wavelengths of electromagnetic radiation. By studying those patterns, researchers can determine what gases are surrounding the object and learn more about its physical environment. This is where powerful observatories become extremely important. The James Webb Space Telescope can observe infrared wavelengths with extraordinary sensitivity. Webb was not designed to search specifically for alien spacecraft. Its role is much more interesting scientifically. It can help researchers investigate what 3I, Atlas is actually made of. Scientists can examine the gases surrounding the object, monitor changes in its activity, and compare its chemistry with objects formed around our Sun. The goal is to determine how similar, or different, planetary building materials are across the galaxy. And that could eventually help answer a much bigger question. How common are the ingredients that produced our own planetary system? For decades, astronomers have studied our solar system as their primary example of planetary formation. But one example is not enough to understand a galaxy. Interstellar objects provide additional samples. Each visitor could become another piece of evidence. There is also a fascinating mystery surrounding the object's birthplace. Although its trajectory clearly indicates an interstellar origin, tracing its path backward over enormous periods is incredibly difficult. The stars themselves move. The Milky Way rotates. Gravitational encounters can gradually alter the trajectories of small objects. After millions of years, even tiny changes can make reconstructing an object's exact history extremely challenging. Scientists can still use computer simulations to investigate possible origins. But the exact star system where 3I, ATLAS formed may remain unknown. And perhaps that mystery is part of what makes the object so fascinating. It may have traveled for an enormous amount of time before humanity ever knew it existed. Now, for a brief moment, this ancient traveler is passing through our cosmic neighborhood. Astronomers have only a limited opportunity to study it. Every observation matters. Every spectrum can reveal another chemical clue. Every measurement can help refine our understanding of planetary systems beyond the Sun. And as 3I, ATLAS continues its journey, scientists are preparing for the next question. What else could objects like this reveal about the universe? Because 3I, ATLAS may not be an isolated curiosity. It could represent the beginning of a new era in interstellar astronomy. The most remarkable thing about 3I, ATLAS may not be what it looks like. It may be where it came from. Somewhere in the Milky Way, around a star that humanity may never identify, material came together to create this object. At some point, gravitational interactions likely changed its path and expelled it from its original planetary system. From there, it became an interstellar traveler. For an immense period, it moved through the space between stars. During that journey, it would have been exposed to cosmic radiation, extremely low temperatures, and occasional gravitational encounters. Then, eventually, its trajectory brought it into our solar system. And humans happened to be watching. That timing is extraordinary. If 3I, ATLAS had passed through our region thousands or millions of years earlier, humanity would never have known. But today we possess observatories capable of studying distant objects in unprecedented detail. The James Webb Space Telescope is one of those instruments. By observing infrared light, Webb can investigate molecules within the gases surrounding 3I, Atlas. These chemical measurements could help astronomers determine whether its composition resembles comets from our own solar system or represents a substantially different type of planetary material. One of the most interesting questions involves carbon dioxide and water. Why does the balance between these compounds appear different from what researchers often observe in familiar solar system comets? The answer could be connected to where the object formed. In planetary systems, temperature changes dramatically with distance from a star. Different materials freeze or remain gaseous at different temperatures. This means the location where a comet forms can strongly influence its chemical composition. If 3I, ATLAS formed in a particularly cold region of another planetary system, its chemistry could preserve evidence of that environment. That would give astronomers a new way to study planetary formation beyond the Sun. It could also reveal whether the processes that created our comets are common throughout the galaxy. Perhaps planetary systems repeatedly produce similar objects. Or perhaps the chemical diversity between systems is much greater than scientists previously expected. 3I, ATLAS could help distinguish between these possibilities. There is another important aspect of the discovery. Interstellar objects are expected to be traveling throughout the galaxy, but most are extremely difficult to detect. They are small. They are dark. And they move through enormous volumes of space. Only a tiny fraction will pass close enough to a star, and only a smaller fraction will be discovered by human telescopes. That means the objects we have already detected could represent only a small sample of a much larger population. Future observatories may discover many more. As detection technology improves, astronomers could begin building a population of interstellar objects and comparing their chemistry. That would be revolutionary. Instead of studying one visitor, scientists could study dozens or potentially hundreds. Then patterns might begin to emerge. Some could contain large amounts of water. Others might be rich in carbon-bearing compounds. Some could resemble our own comets. Others might look completely different. The differences would reveal how planetary systems evolve under different conditions. And there is always the possibility of eventually sending a spacecraft toward one of these objects. Such a mission would be extraordinarily challenging. Interstellar visitors move rapidly, and their trajectories must be determined quickly. A spacecraft would need to launch at exactly the right time and reach the object before it disappears into deep space. But if humanity succeeds someday, scientists could directly analyze material formed around another star. For now, telescopes are our best tools. And that is enough to make 3I-ATLAS remarkable. There is no confirmed evidence that it is an artificial spacecraft. There is no established proof of an encoded transmission or deliberate navigation. The extraordinary part is already supported by observation. It is a natural object from outside our solar system. It traveled through interstellar space and entered our planetary neighborhood. That alone gives scientists something they have wanted for generations: an opportunity to study material produced beyond the Sun. And perhaps 3I-ATLAS will eventually answer questions that are much larger than itself. How are comets created around other stars? How different can planetary chemistry become? How often are objects expelled from planetary systems? And could some of the molecules associated with the development of life be widespread throughout the galaxy? We do not know the answers yet. But that is precisely why the discovery matters. Science does not begin with certainty. It begins with an observation that raises a question. 3I-ATLAS is one of those observations. A traveler from beyond our solar system has crossed our cosmic neighborhood, giving humanity a rare opportunity to study material from another stellar environment. Eventually, it will continue its journey into the darkness. But the information collected during its brief visit will remain here.